So your homework had the light coming from the right. I did not shade my answer keys in, but hopefully with this first one, double check. Did you get that to be a waxing quarter? Did you draw it like that? Okay, then number 2, we should be moving on to the waxing gibbous. Do you have mostly light here on the right, just a little bit of dark on the left? Is that what your waxing gibbous looks like? This is one of the ones people screw up drawing all the time. Don't get a gibbous and a crescent confused. Then we move on to number 3, which would be the full moon. Number 4, we're on to the waning gibbous. So again, double check this one really carefully. Do you have mostly light here on the left with just a little bit of shading on the right? Again, lots of people screw up the gibbous because it's very similar to a crescent. Moving on to number 5, that should be the waning quarter, so half and half with the light on the left. So again, your left side for the waning quarter. Moon number 6, that's going to be a waning crescent. So again, just a little bit of light. It's almost all shaded in, just a little bit of light here on the left. Then we're to the new moon, all shaded in for number 7, and number 8 is back to a waxing crescent. So again, here's my left hand, here's my right hand. So just a tiny bit of light on the right. Here I had a really teeny tiny bit of light. It doesn't have to be that tiny, but make sure it's not close to a quarter. How'd we do? So you're ready for a quiz on moon phases? Oh, yeah. There'll be another take-home quiz tomorrow on moon phases. I would encourage you to do your best, but I would also encourage you not just to solely look up the answers, but to learn from the answers you may look up. So in the meantime, if you guys could now grab your packet, we have one last thing about moons to learn, and that is tides. We're here on this page, which you should have changed to page 23, even though it said page 22. We are on this page labeled tides. All right. How many of you know what a tide is? How many of you have seen tides? Oh, yes, Miss Beachgoer. What do you have to say about the tides? What do you know about the tides? Where are the tides? Let's start there. What kind of beach? The ocean. It has to be the ocean. We cannot go down to Sunset Bay. We can't go over to Evangola and see the tides. We have to go to the ocean. So what do they look like when you see the tides? Or what? How do you experience them? There's a low tide and a high tide. So if you go and you put your stuff out on the beach and you stay there all day, in fact, sometimes you can't stay there all day. What do you want to add to it?
So high tide, like first thing
No, there's a first or a second, to be honest. It's kind of like what first, the chicken or the egg. It's not all how it works, but you're right. It does have something to do with the sun and the moon more particularly, yeah? So we'll go through this. There are 2 high tides every day and 2 low tides every day. So the tides are 12 hours of, like, from one high tide to another high tide. They're about 12 hours apart. For those of you who have not seen the tides, I have, hopefully these still pop up to the right YouTube link. All right, so just a few YouTube videos to show you what tides look like if you haven't seen them. This one's pretty extreme. So this is some bridge somewhere. I just Googled it. I didn't. Yeah. But what you'll see here is over time, this high tide literally covers this bridge wherever this is. It is dangerous. You're right. These people here who are experiencing this high tide need to pay attention because you could literally get stuck on this bridge. This is somewhere in Europe, I Googled. It does look pretty cool, but definitely a little terrifying. Like this, somebody drove to this during low tide, left their car there during high tide. That was a bit extreme. Let's see what else we got here. But we'll go out. We'll see. I'm assuming it shows low tide next. So you can see you can see exactly how that truck got there now. I think that one's kind of neat. Ooh, 3 hours of waves. Okay, no, we're not watching that. That'll just make us all angry. No. No? Make me angry. Let's see what this one is. Apparently it is the same one. All right. That's not what I want to watch. This is one of my favorite ones to watch. This is obviously it's the Bay of Fundy. This is, I believe, in Newfoundland, Canada. And this one's a little harbor, so no beach. So you could see when this video started, the boats were right up there with the docks. Could walk from the dock right onto the boat. And well, 6 hours later, wait till you see what it looks like. 6 hours later, there you go. Your boat is now stranded. There's literally no water left in this. And then we're going back 12 hours after it started. We're back up to normal levels. And headed back down. You may have noticed it did not become nighttime in this time. So it's not necessarily a day and a night thing. Here's one that I like to show. Oh, this is actually the one I like to show here. So here's more of a beach situation. So you can see here's low tide, lots and lots and lots of beach. This one's got ominous music. You see the beach is slowly disappearing. This would be 6 hours from the lowest low tide to the highest high tide, or 6-ish hours. You got to be careful where you put your stuff down at this beach because you don't want it to disappear shortly afterwards. 6 hours and 10 minutes later. There you go. So it wasn't Newfoundland, it was New Brunswick, my mistake. All right. So there are lots of examples of tides. Some places you can see them better than others, but that is what the tides would look like. If you are interested, you could Google some more videos. But here is what goes right at the top of page 23 on the lines. It says, the tides are a rising and falling of the ocean surface. And these tides are a result of the changing positions of the moon and the sun. So this goes right on the top of page 23. Changing position. So where the sun would be in the sky, yeah. Let me just, if you are a doodler, please don't doodle in that blank space. We are going to be writing in them. Now, how can the moon and the sun control the water? Anybody have any ideas? It's the gravitational attraction, yeah. So the moon is actually the one doing the most work. Now, are you gravitationally attracted to the moon right now? Yeah. Is your body being pulled to the moon? No. Okay, we are being pulled to Earth. Why are we being pulled to Earth instead of the moon? Because we're way closer to the Earth. So we are closer to the Earth, so the Earth is pulling us towards it. Well, isn't that true with water too? What would happen if the moon's gravity was so strong that it could pull the water towards it? We wouldn't have water. It would, and we wouldn't have water. So it's not strong enough to completely tug the water towards it, but it is strong enough to pull it just a little bit. So because each individual drop of water is so tiny and not held together like skin and muscles are holding you together, each individual water molecule is tugged a little towards the moon. And because throughout the day, the Earth is rotating, different locations on Earth are closer to the moon. So what I'm saying is, yes, every day, the moon and the Earth are going to move together, but every day, for the most part, the moon's pulled still. It does move a little bit, but it does hold still for the most part. So as the Earth turns, some places are closer and some places are farther away from the moon. So the places closer to the moon are going to feel that tug a little bit more. And what you see here are two different pictures of the sun, the moon, and the Earth. So no matter what, the high tides are always lined up with the moon. Those of you not paying attention to this, you might want to pay attention here about tides. The high tides will always be lined up with the moon. So notice in this first picture, the moon is off to the left, and the H's, which stand for high tides, line up with the moon. Over here in the second picture, the moon's up top, and again, the H's line up with the moon. High tides always follow the moon. Add that bullet. That's the third bullet you should have up there. High tides always follow the moon, or high tides always line up with the moon. High tides always line up with the moon. There is, however, a slight difference between these two pictures. So what I would like you to do in that blank space is see how I put the picture down here at the bottom. Now take that line and go straight up with it. So we're going to put some notes in that blank space. And the one onto the right is going to be called the spring tide. I lied, this is your left. The one on the left is called the spring tide, The one on the right is called the neap tide. Now, it's not spring for the season. It's spring like a slinky that you can pull and push together. The spring tide this happens when the earth and the moon and the sun are lined up in a perfect line. This occurs twice a month, and this is when we're going to get the highest high tides and the lowest low tides. So the greatest change between high and low. What happens is now not only is the moon doing the pulling, but because the sun's lined up with the moon, it really, it gets in on the action and it pulls the water a little bit too. So it's a spring because it stretches out really far and it squishes in really short. So on the spring tide, the high tide will come up the beach really far and the low tide will go back out to sea really far. All of those examples that I showed you were on those extreme spring tides. Now the neap tide goes with that second picture. So now the sun isn't doing anything. It's just the moon working on the tide. So here, this occurs when the moon and the earth are at right angles with the sun. This also occurs twice a month, and this is going to be the lowest high tides and the highest low tides. So in other words, the smallest change between the highs and the lows. I know this seems like a lot of writing, but after this, we're done. You have officially learned all you need to know about the moon for this year now. You know the phases, you know what causes the phases, you can identify the phases, you know the difference between a lunar and a solar eclipse, and now you know what causes tides. That's it for the moon. So when you're done, I'm going to see if you can answer questions about the moon. And that's going to be your homework, which is going to be pages 24 through 27. You have 17 Regents questions about the moon, but you have about 17 minutes to work on them right now. So again, we literally spent time. I was watch the video. She's done that. This is 23 and now just to 34. So again, your homework is now page 24 through 27, questions 1 through 17. I would suggest doing your best, looking up answers. And when I say look them up, I prefer you to look them up in your packet and ask for help if you need it, because you are getting a take-home quiz on this material tomorrow. Oops, I'll go back. Yeah, sorry. 1 second.